So part 2 of 1.21. Function machines. A function works like a machine, as shown in the diagram below. A function is given a name that can be a letter, such as f or g. The notation f of x represents the output when x is processed by the machine. So note f of x is read as f of x. This is very important because you guys will keep seeing these machines later on, or functions, right? So the notation is very important. Make sure you guys read that. F of x. We can also have functions that are called g of x. It could be h of x. So again, the letter in front of it is the name you give the function, and the variable x is the one that it's dependent on. All right. So that means that we should see another x in the equation. It could be like 3x plus 1, or it can even be like x squared minus 5. So again, this is telling us the number that goes in here is the number that we replace x with. When x is put into the machine, f of x, the value of a function for a specific x value, comes out. In this notation, f of x replaces y. For example, y equals 3 of x minus 1 and f of x equals 3 of x minus 1 are equivalent ways to write the same function. So again, what this is telling you is that both y is equal to f of x. So it's pretty much the same thing. We're just writing it a different way. So here, for example, if we have an x value that goes in, x equals 3, for example, right? It goes into the machine. So that would be f of 3. And then it gets processed in here as 3 times 3. And then if we're using this function, 3 minus 1. So you do the math in there, right? So 3 times 3 is 9 minus 1. That gives us the output value, which is equal to 8. So again, y equals f of x, and that's equal to 3x minus 1, right? So if I were to graph this, right, the inputs is 3 and the output is 8. So it would be like a point at 3 comma 8 somewhere on top right there. So that will be part of the function itself. All right. So keeping same function, right? Numbers are put into the function machine. In this case, f of x equals 3x minus 1. And then again, one at a time. So this is processing one thing at a time. You're not putting two numbers in at the same time. You're only putting one number in. So and then the function performs the operations on each input to determine the output. So for example, when x equals 3 is put into the function machine, f of x equals 3x minus 1. The function triples the input, right? That was a 3 times 3 that I just talked about. That's tripling the input, and then subtracts 1, right, to get the output, which is equal to 8. The notation f of 3 equals 8 shows that when 3 is an input into the function named f, the output is 8. All right, so you guys can use other values that we had in the previous table, like for example, f of 0 is equal to negative 1, and that will be our starting value, or our figure 0, some of you guys are calling it. So let's explore more how we're going to input certain values into x here, and then see what happens to the outputs. So first problem right here, part A, calculate the output for f of x equals 3x minus 1 when the input is x equals 14. So find f of 14. So let's do one right here. So f of 14. So again, the number that's in the parentheses is the one that replaces the x value in the other side of the equation. So this is 3 times 14 minus 1. Now, if you need to use a calculator to multiply 3 times 14, that's perfectly fine. Go ahead and use it. And then finish the operation by subtracting 1. So 3 times 14, 3 times 10 is 30. 3 times 4 is 12. Add those two together, you get 42. So that will be 3 times 14, and then take away 1. So that gives us 41. So we can say that f of 14 is equal to positive 41. All right. Now let's see what happens when we try to find the value for f of negative 10. So f of negative 10, again, that's the number that we're going to substitute for x in the equation. So that's 3 times negative 10. And then remember here, you want to make sure that you multiply the signs, right? Take away 1. So 3 times negative 10, that's a positive times a negative. So if we have opposite signs, those are negative. 3 times 10, that's 30. And then take away 1. So negative numbers to me is like owing people money. Like you let me borrow $5 and then you let me borrow 5 more. That means I owe you 10 now, right? I'm still on the negative side though. So you owe me $30 and then I let you borrow $1 more. Now you owe me $31. So add them up, keep the negative sign. And we can say that f of negative 10 would be equal to negative 31. And then finally, part C, if the output of this function is 24, what is the input? That is f of x equals 24. Then what was x? And what was the possible input? So what do you guys think could happen here? So this is, now they're giving this to us backwards pretty much. They're telling us f of x equals 24, right? So what it's asking you is what is the value, what is the x that makes f of x equals 24. All right. So here, what we want to do is substitute. So instead of replacing the x inside here, we're going to replace this whole thing. So that's our equation, f of x equals 3x minus 1. So I want to figure out this value now instead of what's the output. So I'm working my machine backwards. So I'm going to make sure that I can try to do that. So I know the output is 24. So I replace that, 24 equals, and then everything else stays the same, 3x minus 1, right? So we multiplied x times 3, and then we took away 1, and we got 24, all right? So here, we want to figure out what could be the possible outputs. So I know 3 times, for example, 3 times 5 is 15, take away 1, that's 14, so not that close. Maybe 3 times 10 is 30, take away 1 is 29, so we're getting a little bit closer. 3 times 9, I know is 27, take away 1, that's 26. Oh, now we're getting a little bit more closer. And then 3 times 8 so 3 times 8 is 24, minus 1, that gives us 23, so we already went under. So I know my answer has to be between 8 and 9 pretty much. So here, let's try to figure out what the value is. So I know that if at the end here, first I'm going to multiply the inputs times 3 and then take away 1. So I want to figure out what's going on to get 24. So I'm going to work my way backwards. So instead of doing PEMDAS here, we're going to work our way back to figure this out. So here, the last thing we do to it is subtract 1. The opposite of subtracting 1 is adding 1. So I'm going to add 1 here and then 1 over here. So that gives us 25 equals 3 times x. So there's nothing adding, so we're good. Now anything that's multiplying or dividing, we're going to get rid of next. So here, in this case, the 3 is multiplying the x, and we want to make sure we leave x by itself. So 3 times x, divide both sides by 3, and you get x equals 25 over 3, which is 8 1/3, or 8.3 with a repeating decimal.